This video is about the stomach, the anatomy, and its activity in the fasted and fed motor state. We're also going to be talking about gastric emptying as well as the pyloric sphincter. First, we're going to talk about the distribution of food in the stomach. So, first the liquids go, then lower nutrient solids, then the higher nutrient solids. That's really about it with the distribution. But we have the anatomy to talk about. So the upper left portion right here is called the fundus. And this is, it's very distensible and accommodates food right here in the upper portion, the fundus. And then right here is called the cardiac region, or cardia. Or the cardiac stomach. And then we have the bottom part here, it's the antrum. And then finally we have this whole portion, which is the body. And also, it's important to know that this part, the left side, the curvature here, is called the greater curvature. And here it's the lesser curvature. And here we have our pyloric sphincter, and then the duodenum here, and then this is our lower esophageal sphincter, and then the esophagus right above here. And then we're going to have our diaphragm coming here right around the lower esophageal sphincter. So there's 3 different kinds of muscle layers in the stomach, and the muscularis externa. We have the inner oblique muscle, the circular muscle, and then the outer longitudinal muscle. Alright, so in the muscularis externa, the inner oblique muscle layer is the least complete layer. It actually disappears when it gets closer to the antrum. So when we're in the antrum area, you won't see the inner oblique layer. It starts from, there's the oblique layer, cardia to body, and then it starts to disappear. And it's kind of a diagonal layer. The circular muscle is the middle layer of the muscularis externa, and it's the most prominent and the most complete layer. It goes throughout the entire stomach, so we'll see it from the lower esophageal sphincter here to the pyloric sphincter. And then we have the outer longitudinal muscle layer. It's not as complete as the circular. It appears on the top. It appears on the top here, the longitudinal layer, and then it's not really here in the middle, and then it appears again in the bottom layer. It increases in thickness towards the duodenum, which is our duodenum is right here. So we also can divide our stomach in 2 parts. So if we go right in the middle here, this upper portion is called the upper orad. And then this lower portion is the lower And the upper audad or orad is basically, or it's sometimes called the proximal. Its job is to store, not for a long period of time, but it stores from minutes to hours. And then the caudad region, the distal part, its job is to break apart the food. So first we'll talk about in detail about the orad stomach. In the orad stomach, when we say it's the store part of the region, it's the store part, it's not that it stays there for a long time. It temporarily stores food in different layers. It can go from minutes to hours until food, it depends on how much food you have and how much you're ingesting. In the absence of food, the orad region, it has contractions of about 13 millimeters of mercury. But once food is present in the orad region, the pressure drops to about 10 millimeters of mercury contractions. And the pressure drop is due to the muscle relaxing in order to accommodate the food stuff. And this lasts about 30 minutes. So when we are eating our lunch, and if we're eating really fast, we can fit a lot of, up to a gallon of food in there. And we won't know when it doesn't tell us when we're actually full. After the 30 minutes, we start to feel full. And here the contractions, once the food is in, it's actually hyperpolarizing because we want the stomach to relax, which is contrary to when we talk about the caudate stomach, but we'll talk about that later. So the act of swallowing causes the relaxation of stomach. The bolus activates the pharynx and esophagus touch receptors, and it's a receptive relaxation from the pharynx and esophagus touch receptors, and also the vagus parasympathetic nervous pathway. It's causing the relaxation. We know this because if someone has a vagotomy, this ability to do this relaxation is lost. Also, there's a mechanical stimuli on the stomach, the gastric accommodation. The vagus may be involved, intrinsic nervous may be involved, and also hormones like gastrin, CCK may be involved, which decrease contraction and increase distensibility. So that's it about the orad stomach. Now we're going to go into the caudate stomach, which divides according to motor activity. So this is some brief facts about the caudate stomach. So basically, the caudate stomach breaks apart food by its peristaltic contractions. The peristalsis is to break apart and for the gastric emptying and also to contract the pyloric sphincter. It increases in velocity closer to the gastroduodenal junction, and the way it does this is by its contents in the stomach are propelled back in the main body of the stomach, and this is called retropulsion. It's the titrate of the food, and titrate is basically the shredding of food by making it go through a tiny hole, which is through the pyloric sphincter. So it goes through that hole and then it keeps coming back through retropulsion, and this shreds the food into smaller shreds the food into smaller boluses or chyme, and then once it gets smaller and smaller, we have two different activities. We we have the fasted motor activity, which is when we don't have anything in our stomach, and it's hyperpolarized during that time, our muscles are. And then we have the fed motor activity, which our muscles are basically depolarized then, because we have a lot of contractions, the peristaltic contractions